Hello everyone, and welcome to another lecture in my Life in the Universe pandemic series. I hope that you're all doing well, for those of you isolated, looking after yourselves, and for those of you who have the virus, making a speedy recovery. This is another lecture in a series looking at some of the interesting questions in astrobiology, studying life in the universe. And today we're going to think about a question that has loomed large, not just in astrobiology, but also in the popular media. Is there life on Mars? Before we go any further, I should tell you the punchline of this story. The fact is, we don't know at the moment. There are some claims of discoveries of ancient signatures of life on Mars. Some people think that we've already found life on Mars in previous missions, but there is no consensus in the scientific community that we have found evidence for life on Mars. So the question very much remains open. And that's a really important thing, because sometimes when you go on the media, you'll see all sorts of incredible claims for life on Mars. You'll see things like, we're about to discover life on Mars. Sometimes you'll see media channels claiming they predict that NASA is going to find life on Mars in the next 20 years, or that there's a very high certainty of life on Mars. All of this is complete nonsense, and it's important to understand that, because sometimes you'll see things that are very leading. Another headline that was in the on the media recently was the discovery of organic compounds on Mars, complex carbon compounds on Mars, which we know exist on that planet, is consistent with life. And if you think about that for a moment, all sorts of things are consistent with life. The mere presence of rocks on Mars is consistent with life. The fact that Mars has an atmosphere is consistent with life. If something doesn't prevent life, then it's consistent with life. So claiming that organic compounds are consistent with life is a very leading, and I would almost say slightly disingenuous claim. But there's lots of that out there. There's lots of that in the media. And so the idea of the next 20 minutes is to give you an overview of what we currently think about life on Mars, and maybe to help you assess claims that are made in the media. And I should say, I'm not going to sit here in some sanctimonious way and pretend that I have all the answers as well. You should be equally critical of my point of view as well. But what I will try and do in the next few minutes is give you a view that I think most of my planetary sciences and astrobiology colleagues would agree with is the current state of knowledge. And you can go and look up other videos and other sources to think about this question: is there life on Mars? It's a tremendously exciting question. It's one of the major questions in astrobiology, partly because people have been thinking about the possibility of life on Mars for a very, very long time. Mars has always been an interesting world. Quite apart from the biology, the ancients realized there was something quite different about this planet. If you transport yourself back about 2,000 years, you'll find ancient Romans standing there looking up into the night sky, and there in the sky they saw this strange dot that had a reddish hue to it, a slight red colour, and they called this planet Mars after the god of war because of its blood red colour. And today, even today, we call this planet Mars the red planet. It also did some other strange things. The ancients saw that it did a backflip through the night sky, and that was very unusual because most planetary bodies, or most heavenly bodies, they didn't really know whether they were planets or stars then, tended to sit in the night sky relatively static. But this strange world did a backflip, and we understand that now, that when Earth and Mars are travelling around in their orbits around the Sun, from the point of view of the Earth, Mars appears to do a backflip. So long before people became obsessed by biology, Mars was always a little bit of a world that stood aside from other worlds, a world that people had a great deal of interest in understanding. Fast forward a couple of thousand years to the 19th century, and we find people becoming increasingly obsessed with the idea of life on that planet, because it was relatively close by and people had discovered that this planet was close to us, relatively close to us compared to the stars. People began to think maybe it had life. Schiaparelli, Italian astronomer, saw lines on the surface of Mars with his telescopes, and he called these canali, in other words, lines. Percival Lowell took that one step further. An American astronomer became convinced that the canali were not just lines, but real canals, and he became obsessed by the idea that Martians were channeling water from the polar ice caps to their beleaguered cities, their desiccated, beleaguered cities. And he started to write books about the Martians and about these canals, and he became absolutely convinced that Mars was a habitable world that had intelligent civilizations. It's interesting, almost entertaining now, to remember that even in 1900, not much more than 100 years ago, the French Academy of Sciences offered a prize for the first person who could communicate with extraterrestrial intelligence, and Mars was excluded because it was considered too easy. So not much more than 100 years ago, people really were convinced there was life on Mars. And this carried on, this speculation, these ideas about advanced civilizations on Mars, until the space age, until the 1960s, when the United States sent the very successful Mariner spacecraft to Mars to take images of the surface of that world. And what it saw was no canals, no Martians building cities, instead a desiccated, dry wasteland of craters and dusty plains. So in some sense, our optimism about life on Mars was dreadfully crushed during the beginning of the space age, when we realized this was a world that did not harbor civilizations, and it didn't even look like a place that would be particularly good for the simplest forms of life. Then in the 1970s, the Viking orbiters arrived at Mars, and they began to take images of the surface of that planet. And in amongst those grainy, grey images of the surface of Mars, they saw little meandering lines across the surface. And on closer inspection, it appeared that those lines were ancient rivers coursing their way across the surface of Mars. And this changed everything, because it suddenly meant that Mars might have been a world very different from the one that we know today, one with lots of liquid water. And about 30 years ago, if you had looked at those images and said, I think these are rivers and deltas and valley networks, that would have been quite controversial. But fast forward a few decades to the present day, and now we have unequivocal evidence that all of these features were indeed ancient lakes and rivers. Very good evidence, not just from orbit, that allows us to map minerals and show that there are minerals consistent with liquid water on Mars, like clays, for example, clays that you find in your back garden. We find clays on Mars as well, indicative of water interacting with rocks. But we also see lots of evidence for ancient lakes, sediments, and on the surface, of course, we've sent rovers. And the Curiosity rover has seen pictures of sedimented layers of rock lined up, one after the other, evidence of mud settling out in ancient lakes inside craters on Mars. So today, there is no ambiguity and there is no controversy about the fact that Mars once had abundant liquid water. And liquid water is one of the fundamental requirements for life. So we should point out right from the beginning here that certainly there's reason to be optimistic that Mars might have been a planet suitable for life. We just don't know whether it harboured life. We know that it had liquid water in contact with volcanic rocks in its early history. And if you go to an environment on the Earth, like Iceland, that also has abundant liquid water in contact with volcanic rocks, you'll find that these environments are teeming with microbes, teeming with bacteria, archaea, these sort of single-celled microbes that inhabit these extreme environments. So if environments like this on the Earth harbour life, could environments on Mars have similarly harboured life? Well, that's the question, and we don't have an answer to it, but it is very, very thrilling. We know that Mars deteriorated over time. If you look at Mars today, it certainly does not harbour liquid water on its surface. In fact, the atmosphere of Mars is about 1/100th as thick as the atmosphere of the Earth. And that means that on the surface of Mars, liquid water is not stable. It tends to bubble and boil away. If you take some ice on Mars and you heat it up, it turns instantly into vapor and bypasses the liquid phase of water altogether. We call this process sublimation. And that is because the atmosphere of Mars is at the triple point of water, where all three phases of matter coexist, and liquid water is generally, across most areas of Mars, across most of the year, unstable. And as liquid water is a fundamental requirement for life, the lack of liquid water on Mars makes it an uninhabitable environment, a very bad, poor place for life. Quite apart from all the other extremes on the surface of Mars today, like the high ultraviolet radiation and the high ionizing radiation, particles streaming in from space, from the sun, that make the surface of Mars a very, very inhospitable place. This is one of the reasons why we think that the surface of Mars is not a good place for life. So what's interesting about Mars is not so much the fact that it had liquid water in its past. In some sense, that's not surprising. Mars is a little bit like the Earth, a rocky planet that condensed out of the protoplanetary disk when our solar system formed. And like the Earth, you would also expect liquid water to have condensed on its surface, as indeed it did. So the surprise actually is not the fact that ancient Mars looked like a habitable environment of liquid water. The surprise is the fact that Mars deteriorated, environmentally deteriorated over billions of years and became the dry, dusty world that it is today, compared to Earth, which remains a biologically fecund planet with lots of liquid water and giant oceans. Why was this the case? Why did Mars become an Earth, if you like, that didn't quite make it? Well, the major reason is that Mars is too small. It's about 50% of the diameter of the Earth, and that has major consequences for the planet. First of all, because Mars is small, it means that the escape velocity, in other words, the speed you need to go to escape Mars's gravity, is about half that of the Earth. And that means that if you heat up atmospheric gases, like in asteroid impacts or comet impacts on the planet, that atmosphere will heat up, and because the escape velocity is a lot lower, many more of those heated up atmospheric molecules will be able to escape from the planet into space and drift out into space, essentially thinning the atmosphere. So that was one major problem with Mars. Because it was small, in the early history when it was being bombarded by asteroid impacts, a lot of that atmosphere was lost, dissipated, and it became the thin atmosphere that we see today, incapable of supporting liquid water on its surface. Another problem for Mars is that because it was small, the centre of the planet cooled down a lot more quickly than the Earth. And the result of that was that it lost its magnetic field. And on our own planet, the magnetic field protects us from all those solar particles streaming in and bombarding our atmosphere and sputtering it away. If you don't have a magnetic field, your atmosphere is more exposed to solar particles, and we think that that contributes to a loss of the atmosphere. On Mars, because the planet cooled down a lot more quickly, the magnetic field disappeared very early in its history, and so the atmosphere was exposed to all those particles streaming in from space, and more of the atmosphere was sputtered away. So the effects of asteroid impacts heating up the planet, atmospheric sputtering, all of these things made the atmosphere thinner than it is or was in the past history of the planet, and as a result, the surface is no longer suitable for liquid water. And all of this caused by the fact that Mars is smaller than the Earth. And you might like to speculate, and this is a fun speculation, about what would have happened if Mars had been larger than it is, if it had been large enough, like the Earth, to sustain a magnetic field and a thicker atmosphere. Would we actually have two planets in our solar system that support biospheres, possibly even intelligent civilizations? Who knows? But Mars was too small and it lost its atmosphere, and the environment deteriorated. The planet transitioned from an early history when there was lots of liquid water in contact with rocks through a period where there was a lot less water, and as a consequence the planet became slightly acidic. And we can understand that if we think about the fact that volcanoes emit gases like sulfur dioxide, and sulfur dioxide mixes with water and forms sulfuric acid. And that sulfuric acid, a very strong acid sometimes, can attack rocks and break them down and make all sorts of salts like sulfate salts. And this is what happened as the water disappeared on Mars. There was less water. The little water that did exist mixed with sulfur dioxide from volcanoes, made sulfuric acid, and created lots of sulfur-bearing minerals on Mars. And we see those today: magnesium sulfate, iron sulfite, jarosite. All of these things are testament to a time when Mars passed through a period of its history where there was very little water, and that water that did exist tended to become quite acidic. And then eventually even that water disappeared, and Mars transitioned into the planet that we know today, the dry, desiccated world that seems so lifeless. So what does all this tell us about life? Well, it tells us that in the early history of the planet there may have been conditions suitable for life. When all those rivers and those lakes existed on Mars, perhaps there were habitats there that could have supported life. Simple bacteria, maybe something different, something more primitive than the bacteria and archaea, the types of microbes that we find here on the Earth. So one thing we could do is go and look for evidence of this life in ancient rocks on Mars, and indeed that is one of the objectives of Mars missions, is to go and look at rocks to find organic signatures or maybe even fossil signatures of this ancient life. The other thing we could do is to go and look at present-day life on Mars. Maybe although the surface of Mars today is inhospitable, there could be life eking out a living in some oasis deep underground. And scientists are very interested in looking under the surface of Mars because that may be the most likely place to find life on Mars today, if it still exists. But that's very challenging because it's difficult to drill into the surface of Mars. It's difficult to get kilometers underground where you might want to get to try and find this life in the deep subsurface of Mars. But we might be able to do it. We might be able to explore lava tubes or caves and find evidence for life. We can use radar to look for subsurface underground liquid water. And last year there was a tantalizing claim that a giant lake had been discovered underneath the south pole of Mars. Still remains to be corroborated, but if it's true, that might mean that there are great bodies of liquid water underneath the surface of Mars. Are they habitable? Do they have the conditions for life? We don't know, but they might certainly be good places to look for life. So at the moment, what's on the menu is past life on Mars in the form of fossil evidence, whether that's remains of the biology itself, or present-day life that is probably underground that will be quite challenging to look for. What sort of life was this, if it existed at all? Well, it's probably, what we're looking for is probably something cellular, something like bacteria and archaea, which are two domains of life on Earth. And these similar sorts of life might have existed on Mars. We could also try and look for evidence of life that is completely different from life on Earth. We can't really speculate on entirely novel biochemistries, but maybe if life on Mars had evolved independently of life on Earth, we might try and find life on Mars that looks very different or has very different biochemistry to life on Earth. It's a matter of great debate in the scientific community as to whether if we did ever find life on Mars, would it be like life on Earth, maybe even related to life on Earth, having been transferred to Mars in pieces of rocks, thrown up by asteroid and comet impacts on our planet and landed on Mars? Or would life on Mars be an independent origin of life, a completely new origin of life with a different biochemistry? Well, again, that is speculation. We don't even know whether there is life on Mars, let alone whether it is related to life on Earth or something completely different. But these are the thoughts that occupy the minds of scientists trying to think about ways you would search for that life, because of course these ideas influence the types of instruments we build to look for life on Mars. Well, this is the Life in the Universe pandemic series, so we can't let our little friend coronavirus go so easily. What about viruses on Mars? Well, people have thought about this. Viruses, of course, need cellular life to replicate. They can't replicate on their own. They need to get into a cell and hijack that cell to be able to replicate themselves. Could there be viruses on Mars? Well, certainly on Earth, there are many viruses associated with not just humans, but with bacteria, a vast number in our biosphere. And most of us think about viruses in terms of disease and coronavirus as things that attack humans. But there are viruses that attack bacteria as well. And these are called phages or bacteriophages. And these are viruses that go after bacteria instead of human beings. And in the ocean, for example, there can be 10 times as many viruses as bacteria. So a vast number of them. We don't really know how viruses evolved. People have different ideas. Some scientists think that viruses were large cells that lost some of their genes and became smaller. Some people think that viruses are bits of membranes that pinched off from cells and then became dependent on cells. Some people think that they're completely different entities. All of those explanations might be realistic. It could be that viruses come from multiple origins. But we do know that on our own planet, once cellular life evolved, viruses came along with them and started to become associated with the expansion of cellular life. In fact, we think that many viruses are quite primitive. So if there was cellular life on Mars, bacteria, archaea-like microbes on Mars, it's not outlandish to expect that there would be small particles associated with those cells that could be virus or virus-like particles that we find here on the Earth. Martian viruses. Now there's something to think about. But that's really a second-order question. The first-order question we have to ask is there any life on Mars at all? And at the moment, we don't have any good evidence to suggest unequivocally that there is life on Mars. But we are getting close to it, and I think what's tantalizing is the fact that we now have images and data from ancient lakes on Mars and other environments that would be outstanding places to test the hypothesis of, is there life on Mars? The question, is there life on Mars? And in the next few decades, we might finally get some sort of answer. So when the media says NASA is going to discover life on Mars in 20 years, that is nonsense, because we can't say that at the current time. But that's not to say that we won't discover life on Mars in 20 years. We simply don't know the answer. But certainly in the next 20 years, we should have some sort of answer as to whether there is life on Mars or not. So that's where we stand at the current time. And in future lectures, maybe we'll explore a few more of these ideas in a little bit more detail. So thanks a lot for attending this lecture. Keep well and speak to you later.